Hello, good day and welcome. I will be answering Wassce 2020 Physics Past Question 1. In a collision between two objects, kinetic energy is conserved only if A. One of the objects was initially at rest, B. Potential energy is converted to work, C. The collision is inelastic, and D. The collision is elastic. So the question says, in a collision between two objects, kinetic energy is converted only if. Now, when there's a collision between two objects, there are two forms of this collision. It's either the collision is it's an elastic collision, or an inelastic collision. Now, for an elastic collision, the total kinetic energy is the same before and after the collision. That is, both momentum and kinetic energy is conserved. So in an elastic collision, or what we refer to as a perfect elastic collision, the kinetic energy and the momentum of the bodies involved in this collision is actually what's constant. That is, it is conserved before and after the collision. So both momentum and kinetic energy Ke is conserved. Now, in an inelastic collision, only momentum is conserved. Now, the kinetic energy Ke decreases after collision for an inelastic collision. So in an inelastic collision, only the momentum is conserved, but the kinetic energy now decreases after collision. Now the question says, in a collision between two objects, kinetic energy is conserved only if the collision is an elastic collision, because in an elastic collision, both momentum and the kinetic energy is conserved. The total kinetic energy before and after the collision remains the same. So the answer to this question is option D. The collision is elastic. Thank you very much, and ensure to subscribe to our channel for more videos. Hello, good day and welcome. I will be answering Wassce 2020 Physics Past Question 2. The quantity of motion of a body is its A. Acceleration, B. Displacement, C. Momentum, and D. Velocity. The question says the quantity of motion of a body is its. Now let's briefly describe each of these. A says acceleration. Now acceleration is simply defined as the rate of change of velocity. That is, acceleration A is given as velocity all over time. So the rate of change of velocity, and that is acceleration. Now B says displacement. Now displacement is simply the distance covered with specified direction. Now displacement is similar to distance, but the only difference is that displacement is a vector quantity while distance is a scalar quantity, and so displacement has to do with direction. Now C says momentum. Now momentum is simply defined as the product of mass and velocity of an object. Thus, it increases with increase in the object's mass and the velocity. Now we can therefore say that momentum is the quantity of motion of a body. We can therefore say thus that what it is the quantity. It is the quantity of motion of a body, because what it is given as the product of the mass and velocity, that is momentum. Let's say m is given as what? Mass times velocity. Mass times velocity, the mass of the body times the velocity of this body. So therefore this what sum up the quantity of motion in that body, motion being the velocity and the quantity being the mass. So the quantity of motion of a body is what is the momentum. Now this is velocity. Velocity simply means what? The rate of change of distance with time. Rate of change of displacement with time. Of displacement with time. That means displacement and velocity v is equals to what? Displacement all over time. So the answer to this question is option C, momentum. That is the quantity of motion of a body, that which is given as the product of mass and the velocity of that body. Thank you. Please ensure to subscribe to the channel for more videos. Hello, good day and welcome. I'll be answering Wassce 2020 physics past question 3. The volume of a fixed mass of gas varies inversely as the pressure on it, provided the temperature is constant. The statement is A. Pressure law, B. Chau's law, C. Boyle's law, and D. General gas law. Now the question says the volume of a fixed mass of gas varies inversely as the pressure on it, provided the temperature is constant. That this statement is which law? Now let's just quickly pick each of these law and look at how they are stated. Now pressure law. Now pressure law states that the pressure of a fixed mass of gas at constant volume is proportional to the absolute temperature of the gas. Is proportional to the absolute temperature of the gas. Now this is what the pressure law stated by Gay-Lussac's. Now B says Chau's law. Now Chau's law states that the volume of a fixed mass of gas increases by 1/273 of its volume at 0 degree Celsius per degree rise in temperature, provided its pressure remains constant. Now this is Chau's law stated by Chau's. Now option C says what? Boyle's law. Now Boyle's law is stated as the pressure of a fixed mass of gas is inversely proportional to its volume, provided that the temperature is kept constant. So that is what Boyle's law. Now this is general gas law. Now the general gas law is the combination of Boyle's law the combination of Boyle's law and Charles' law. That is the general gas law. So general gas law is the combination of what? The Boyle's law and Charles' law. Now the question says the volume of a fixed mass of gas varies inversely as the pressure on it. And I said Boyle's law state that the pressure of a fixed mass of gas varies inversely as its volume. Now it is the same thing as still saying what the volume of a fixed mass of gas varies inversely as the pressure. So therefore, this statement is actually what? A statement of Boyle's law, because the volume of a fixed mass of gas varies inversely as the pressure. That is, when you have the volume increasing, the pressure what? Decreases. Increase in volume will lead to a decrease in the pressure, and increase in pressure will lead to a what? A decrease in the volume. That is what? That is Boyle's law, because it is what? The volume is inversely proportional to the pressure, and this law is Boyle's law, option C. Thank you. Ensure you subscribe to the channel for more videos. Hello, good day and welcome. I will be answering Wassce 2020 Physics Past Question, question 4. An image formed on a screen is always A. Inverted, B. Magnified, C. Upright, and D. Virtual. So, now an image formed on a screen is always a what? A real image. Is a real what? Image. Any image that can be caught on a screen. Image that can be caught or formed on a screen is a real image. Now, real images are always what? Inverted. Remember, we have two types of image. We have the real image and the what? Virtual image. So real images are always inverted. They are always inverted. Now for the virtual image cannot be caught on the screen. That is, they cannot be formed on the screen. They cannot be formed on the screen. So the answer to this question is what? Option A, because images formed on a screen are real images, and real images are always what? Inverted. So the answer to this question is what? Option A, inverted. Thank you. God bless you. And just subscribe to our channel for more videos. Hello, good day and welcome. I will be answering Wassce 2020 Physics Past Question, question 5. How would capacitance of a parallel plate capacitor be affected if the distance of separation of its plates is decreased? It will A. Increase in value, B. Decrease slightly, C. Remain unchanged, and D. Drop to 0. Now we're asked to describe how the capacitance of a parallel plate capacitor will be affected if the distance of separation between its plates is decreased. Now the capacitance of a capacitor, that's a parallel plate capacitor, is inversely proportional to the distance of separation between the plates of this capacitor. And this can be seen in the relation where you have capacitance C is equal to the constant multiplied by the area all over the distance of separation. Now you will see that what? This capacitance is inversely proportional to what? To the distance. That is, C, the capacitance is inversely proportional to the distance of separation between what? These plates. Now because of this inverse proportion, when there's an increase in the distance, that is, when you have an increase in the distance of separation between these plates, you have a what? A decrease in capacitance. But when there's a decrease in distance between the plates of this capacitor, there will be an what? There will be an increase in the capacitance. Now the question says, how would the capacitance of a parallel plate capacitor be affected if the distance of separation is decreased? Now when the distance of separation is decreased, due to the inverse proportion, the capacitance will do what? Will increase. The capacitance will increase, and this is option A. So it will increase in value. Thank you, and you should subscribe to the channel for more videos. Hello, good day and welcome. I will be answering Wassce 2020 Physics Past Question, Question 6. Which of the following machines does not apply the lever principle? A. Claw hammer, B. Wheelbarrow, C. Single pulley, and D. Sugar tongue. Like we know, machines as what machines are equipment that are used to what overcome large resistance by applying small or simple what efforts. Now a lever is a type of machine, and this lever what covers several what equipment or tools that makes use of this what principle, the lever principle. Now this lever principle enable large resistance to be overcome with little force. And in terms of the lever principle, a lever has what we call a fulcrum. A fulcrum. Let's say for instance, this is a simple what representation of a lever. Now this point here is what we call what? The fulcrum. We call this the fulcrum or pivot. Then now where the effort is applied, let's assume effort is applied here, we call this part the what? The effort E, and where the load is applied or where the load is placed, we call it what? We call it the load L. Now this lever principle has what? Work on three forms. We have the what? We have the first order lever, the second order lever, and the third order lever. So the first order lever, the second order lever, and the third order lever. And this is actually what's based on the position of the three main parts of a lever, that is the effort, the fulcrum, and the load. But now the question says, which of the following machines does not apply the principle of lever, that is lever principle? Now the examples of machines that apply what the lever principle includes, let me list them for us. We have the scissors. We have the scissors. The scissors what? The scissors applies the lever principle, and that is the first order principle. The first order principle. Also we have the claw hammer. The claw hammer, also the first order principle or the first order lever. We have the wheelbarrow. We have the sugar tongue, forceps, and so on. Now the question says, which of the following machine does not apply the lever principle? Now you can see claw hammer applies the lever principle, likewise the wheelbarrow and the sugar tongue. But option C here says what? Single pulley. Now a pulley or a pulley system is a type of machine, it's another type of machine that do not apply what? The lever principle. This pulley system is usually used to what? It's usually used to raise or lower heavy loads. Used to raise lower or heavy loads. Now a pulley is described like this. Let me give you a diagrammatic representation of a pulley. Take for instance, you have something like this where it is attached, then you have it like this. Now the effort is applied here. The effort is usually applied here, and then the load is what will be suspended on this pulley system like this. Here will be the load. So now the effort being applied here what will enable what you to leave this load. So this is a representation of what? A pulley system. You can see that this pulley system is different from the lever principle. This other machines here apply the what? Lever principle, except option C, which is single pulley. So option C is the answer to this question. Thank you and God bless you, and subscribe to the channel for more videos. Hello, good day and welcome. I'll be answering Wassce 2020 Physics Past Question, question 7. The average distance moved by a molecule between collisions is called A. Molecular distance, B. Intermolecular distance, C. Mean distance, and D. Mean free path. Now, let's analyze each of these options to get out our answer. Now, molecular distance, that's option A. Molecular distance is simply what the distance. This is the distance between atoms of the same molecule. That is, atoms of the same molecule. The distance between atoms of the same molecule is what we call the molecular distance. Now, B says intermolecular distance. This is the distance between different molecules or two molecules. Now, mean distance. This is the average distance between molecules of any element. Now, mean free path. Mean free path is the average. Mean free path is the average distance traveled by a moving particle. This particle can be an atom, it can be a molecule, between successive collision. Between successive collision. So mean free path is the average distance moved by or traveled by a moving particle between successive collision. And the question says the average distance moved by a molecule between collisions is called D. Mean free path. This is the answer to the question, mean free paths. Thank you and God bless you. And subscribe to the channel for more videos. Hello, good day and welcome. I will be answering Wassce 2020 Physics Past Question, question 8. Which of the following requires material medium for its propagation? A. Radio wave, B. Light wave, C. Sound wave, and D. X-ray. Now, we're asked to pick an option which is a wave or a type of wave that requires material medium for its propagation. Now, like we know, we have two types of waves based on the need for a material medium for propagation, and this is the mechanical wave, and the electromagnetic wave. Now, the mechanical wave are waves that requires material medium for propagation. That is, this type of wave cannot be propagated in a vacuum. And example of a mechanical wave include the sound wave. We have the water wave, and so on. Now, electromagnetic wave, on the other hand, are waves that do not require material medium. They do not require material medium for propagation. An example of this wave are the radio wave, e.g. we have the radio wave, we have the X-ray, light wave, and so on. Now, this electromagnetic wave can be propagated in a vacuum. A vacuum is an empty space. Now, mechanical waves, like I said, requires material medium for their propagation, and the question is asking us about mechanical wave. And an example of mechanical wave is sound wave, which is option C. So therefore, sound wave is the answer to this question, because sound wave is a mechanical wave which requires material medium for its propagation. The other options here are electromagnetic waves that do not require material medium for propagation. And this sound wave requires material medium. The denser the medium, the faster it was speed of propagation. So the answer to this question is what? Option C, sound wave. Thank you and God bless you, and should subscribe to the channel for more videos. Hello, good day and welcome. I will be answering Wassce 2020 Physics Past Question, question 9. The depolarizing agent in a Leclanche cell is A. Carbon rod, B. Ammonium chloride, C. Manganese 4 oxide, and D. Zinc plates. Now, a Leclanche cell is a what? Is a type of wet cell. Although we have the wet and dry Leclanche cell, but the Leclanche cell actually described here is the word wet Leclanche cell. Now, this Leclanche cell has various components. That is its positive terminal, its negative terminal, the depolarizing agents, and the electrolytes. But the question is asking us to identify the depolarizing agents in a Leclanche cell. Now, in a Leclanche cell, the positive terminal is the carbon rod, and that is option A. Now, the negative terminal is the what? Zinc plates, and that is option D. Now, the electrolytes is what? Is the ammonium chloride. And that is option B. And now the depolarizing agents is the manganese 4 oxide, and that is option C. So manganese 4 oxide is the depolarizing agent in a Leclanche cell. Thank you and God bless you, and should subscribe to the channel for more videos. Hello, good day and welcome. I will be answering Wassce 2020 Physics Past Question, question 10. The material used to slow down the neutrons in a nuclear reactor is A. Boron, B. Copper, C. Graphite, and D. Uranium. So we're asked to pick an option which is the material used to slow down nuclear reactors. Now, materials used to slow down nuclear reactors are what? We call them moderators of nuclear reactors. Any material that is used to slow down nuclear neutrons in a nuclear reactor are called what? Moderators. We call them the moderators of nuclear reactors. They help to slow down the neutrons. In some other terms, you can call them what? Coolers. So they are moderators of nuclear reactor that slows down neutrons. Now, an example of a material that is used to slow down neutron is the uranium. Uranium is a typical example of a material used to slow down neutrons in a nuclear reactor. So uranium is known as a moderator of nuclear reactors, and that is option D, uranium, which is the answer to this question. Thank you and God bless you, and should subscribe to the channel for more videos. Hello, good day and welcome. I will be answering Wassce 2020 Physics Past Question, question 11. Which of the following statements explains why hot soapy water is more effective in cleaning oil-stained dishes? A. The oil on the dishes repel the soap. B. Soap and heat decreases the surface tension of water. C. Hot water increases the surface tension of oil. And D. Soap increases the surface tension of oil and water. Now, we know or we observe that most of our dishes or oil stained dishes are usually washed with what? With either soapy water or hot soapy water. Now, this is because hot soapy water helps to reduce the surface tension. Hot soapy water helps to reduce the surface tension of water. And by doing this, by reducing the surface tension of water, it enables what? Enables the oil particles, that is the oil particles on these dishes, to what? To float away, thereby cleaning our dishes. So this reduction of the surface water tension of the water enables what? Enables the water to wet these dishes. Now when the water is able to wet these dishes, it then what? It then floats away the oil particles, from the dishes, and like we know that what? Heat and soap or detergent helps to what? Helps to lower the surface tension of water, and that is why hot soapy water is very what? Important in cleaning oil stained dishes. Like I said, it will what? It will reduce the surface tension of this water, making the water able to what? To wet the dishes. Now when this water wets the dishes, it will now have the ability to what? To float away the oil particles on these dishes. And like surface tension is the force acting on the surface of water, making it to behave like a stretched elastic skin. So when this surface tension is reduced by the heat or the soap, that is the hot soapy water, what happens? It enables it to float away these oil particles from the dishes, thereby cleaning our dishes. So therefore the answer to this question is option B, because soap and heat decreases the surface tension of water. So option B is the correct answer to this question. Thank you and God bless you, and subscribe to our channel for more videos. Answering Wassce 2020 Physics Past Question, question 13. An electrical device has 50 turns in its primary coil and 20 turns in the secondary coil. The device can be A step-up transformer, B step-down transformer, C DC generator, and D AC generator. Now, an electrical device with a primary coil and a secondary coil is typically what? A transformer. Now, a transformer is a device or an electrical device used for changing the size of an alternating current voltage. That's an AC voltage. So in other words, it acts to increase or decrease the EMF, that is the electromotive force of an alternating current. Now there are two types of transformer. We have the step-up transformer, and then we have the step-down transformer. Now for the step-up transformer, it helps to increase or step up the applied voltage or primary voltage. And this is actually done because the secondary coil of a step-up transformer has more turns than the primary coil. So when you see a step-up transformer that is used to step up or increase the primary voltage of an alternating current, the secondary coil always has more turns than the primary coil, in the sense that, let's take for instance, you have 20 turns in the primary coil. The secondary coil will have more than 20 turns. It might have 50 or 100 turns, because you are trying to increase the primary voltage. But in terms of the step down transformer, you're trying to decrease the primary voltage. You're trying to decrease the primary voltage, or step down the primary voltage or applied voltage. And because of that, the primary turn and coil usually have more turn than the secondary coil. That is, the secondary coil has less turns compared to the primary coil, because you are trying to step down or decrease the applied voltage or primary voltage. Now the question says an electrical device has 50 turns in its primary coil and 20 turns in the secondary coil. Now you agree with me that here now the primary coil has more turns than the secondary coil, and so therefore it is a step down transformer, because the main aim here is to decrease the applied voltage here. And like we say, the step down transformer helps to decrease primary voltage or applied voltage, and this is because the primary coil usually have more turns than the secondary coil, unlike the step up transformer, that's the secondary coil has more turns than the primary coil. So the answer to this question is what? Option B, step down transformer. Now we didn't look at generators, DC generator or AC generator. This is because generator is a device that does what? That actually is used to convert magnetic energy towards to electrical energy. So it works on the principle of electromagnetism, whereby magnetic energy is used to produce electricity. That's in terms of the generator. So magnetic energy is used to produce electricity. But the device that we have been described here is is a transformer, and that is the step down transformer, which is option B. Thank you and God bless you, and subscribe to our channel for more videos. Hello, good day and welcome. I will be answering Wassce 2020 Physics Past Question, question 14. The earpiece of a telephone handset converts energy from dash to dash. A, from electrical to sound. B, from sound to electrical. C, from radio wave to sound. And D, from sound to radio wave. Now, the earpiece of a telephone works on the principle of electromagnetism. It works on the principle of electromagnetism. Now, the telephone earpiece is a device. It's a device which converts the varying electric energy from the microphone. That is, it receives electric energy from the microphone and converts it into varying sound energy. In other words, the telephone earpiece is simply an electrical device that converts electrical energy into sound energy. Now, this electrical energy is actually received from from a microphone, and the microphone is also an electrical device that converts sound energy into an electric energy. So when you speak to a microphone, this sound energy will be picked by this microphone and then converted to electrical energy. Now, this electrical energy from the microphone will be sent to the telephone earpiece, which then converts this electrical energy into sound energy that enables us to hear the sounds or the vibrations. So the answer to this question is option A, electrical energy to sound energy. Thank you and God bless you, and subscribe to the channel for more videos. Hello, good day and welcome. I will be answering Wassce 2020 Physics Past Question, question 16. A ray of light traveling from glass into ethyl alcohol is incident at the boundary at an angle of incidence 30 degrees. Calculate the angle of refraction. Now, given that the refractive index of glass is equal to 1.5 and the refractive index of ethyl alcohol is equal to 1.36. Now we are asked to find to calculate the angle of refraction. The angle of refraction. Now, for us to calculate the angle of refraction, we must know the refractive index of this boundary where the light or this light ray actually crosses. Remember, the angle of the refractive index for glass, that is of the light moving from air to glass, is 1.5, and the refractive index of light moving from air to ethyl alcohol is 1.36. Now we'll have to find the refractive index of the light moving from glass to alcohol, and this is giving us refractive index from glass to ethyl alcohol, and this is equal to the refractive index of glass all over refractive index of ethyl alcohol, and this is equal to 1.5 all over 1.36, and we'll have 1.103. Now this is the refractive index of the light rays moving from glass to ethyl alcohol. Now we can now see the refractive index of the light moving from glass to ethyl alcohol is equal to sine angle of incidence all over sine angle of what? Refraction. Now we can now see 1.103 is equal to sine 30 all over sine r. Remember I have to find what? R. Now from here we can see what? Sine r, that's sine angle of refraction, is equals to sine 30 degree sine 30 degree all over the refractive index of light moving from glass to ethyl alcohol, and that is 1.103. And sine 30 degree will give us what? Will give us 0.5. Now all over 1.0103. Now to find r, we simply what? Take the what? The sine inverse of this. So we now say r is equals to what? Sine inverse of 0.5 all over 1.103, and this will give us 27 degree. That's approximately what? 27 degree. Now when you take the sine inverse of 0.5 all over 1.103 in your calculator, when you punch it on your calculator, you get what? 26.9 something, and so approximately that is what? 27.0 what? Degree, and that is option A, 27 degree. So this is the what? Angle of refraction. Thank you and God bless you, and sure to subscribe to our channel for more videos. Hello, good day and welcome. I will be answering Wassce 2020 physics past question 17. A 60 kg man stands on a wind balance in an elevator. If the elevator accelerates upward at 5 meters per second square, determine the reading of the scale. A 300 Newton, B 600 Newton, C 800 Newton, and D 900 Newton. Now the man has a mass M of 60 kg. Now he stands on a weighing balance, that is, he's trying to check his weight on a weighing balance, but now inside an elevator, and this elevator is accelerating upwards at what? 5 meters per second square. Now accelerating upward against what? Against gravity. Is going what? Against gravity, because it's moving what? Upward, accelerating upward is against gravity, and the what? Acceleration due to gravity, G, is equal to 10 meters per second square. Now to find the weight of this man, that is which is the reading of the scale, that is the weighing balance, we must what? Subtract this what? Acceleration of the elevator from the acceleration due to gravity, because the man is moving what? Against gravity. So therefore the weight of the man, or the reading of the scale, is equals to the mass multiplied by what? Acceleration due to gravity minus the what? Acceleration of the elevator, and this is equals to 60 multiplied by 10 minus 5, and this is equal to 60 multiplied by 5, which is equals to 300 Newton. So the weight of this man is 300 Newton, and that is option A. Thank you and God bless you, and sure to subscribe to our channel for more videos. Hello, good day and welcome. I will be answering Wassce 2020 physics past question 18. The length of an iron bar is 100 centimeter at 20 degrees Celsius. At what temperature will its length increase it by 0.01%? Now, given that the linear expansivity of iron is equal to 1.2 times 10 raised to the power of minus 5 degree, that's per degree Celsius. A 48 degree Celsius, B 38 degrees Celsius, C 28.3 degrees Celsius, and D 23 degrees Celsius. So we have to find what? The temperature at which its length will increase by 0.01%. Now the formula for finding the linear expansivity of a given ion or a given metal is given as alpha is equals to L2 minus L1 all over L1 into theta 2 minus theta 1, that is change in temperature. Now this L2 minus L1 is the increase in length, and that can be represented as E increase in length is equals to L2 minus L1. So we can therefore say that alpha is equals to E all over L1 into theta 2 minus theta 1. Remember, I say L1 is E is the increase in length, that is L2 minus L1, and we are given that the increase in length is by 0.01%. So therefore E is equal to 0.01 all over 100 multiplied by 100, which is L1. So we are trying to get the increase in length. Now the initial length is 100 centimeter. So to get the increase in length, since this is 0.01% of this, which is 0.01 over 100 multiplied by 100, now this 100 will cancel this 100, so we have that increase in length is equal to 0.01 centimeter. 0.01 centimeter, that is the increase in length. Now we have that L1 is equal to, that's the initial length is 100 centimeter. Then we have that our first temperature, that is initial temperature, theta 1 is equal to 20 degrees Celsius, at which the length of this ion is 100 centimeter. Then we are asked to find the temperature at which it will increase by 0.01%, and that is theta 2. Now we have that the linear expansivity is equal to 1.2 times 10 raised to the power of minus 5 per degree Celsius. Now from this formula here, we can deduce that theta 2, which is what we are asked to look for, theta 2 is equal to the increase in length all over linear expansivity multiplied by the initial length plus the initial temperature, which is theta 1, from this formula. Because when you multiply both sides by this, you saw in cross multiply this this linear expansivity will multiply this, leaving U with E here on the right hand side. Now when you divide both sides by the linear expansivity and the initial length, you have theta 2 minus theta 1 here equals to E all over linear expansivity multiplied by the initial length. Then now adding the initial temperature to both sides will now give you this formula. So this is the formula we're going to be using. Theta 2 is equals to increase in length E all over the alpha, which is the linear expansivity, multiplied by L1, which is the initial length, plus theta 1, which is the initial temperature. So we have that theta 2 is equal to, now E, the increase in length, is 0.01 centimeter, 0.01 all over, now alpha, linear expansivity, 1.2 times 10 raised to the power of minus 5 multiplied by L1, which is 100, then everything plus theta 1, which is 20. Now we'll have that theta 2 is equal to 8.3 plus 20. Now when you carry this out, this is 1.2 here. When you carry this out, this 0.01 all over 1.2 times 10 to the power minus 5 multiplied by 100, it will give us 8.3. Now 8.3 plus 20 will give us will be equals to 28.3 degree Celsius, and this is the temperature at which the length will increase by 0.01%, and that is option C, 28.3 degree Celsius. Thank you and God bless you, and share subscribe to the channel for more videos. Hello, good day and welcome. I will be answering Wassce 2020 Physics Past Question 19. A moving coil galvanometer which gives a full-scale deflection with 0.005 amperes is converted to a voltmeter reading up to 5 volts using an external resistance of 975 ohms what is the resistance of the meter, that is the resistance of the galvanometer? A 0.25 ohms, B 2.5 ohms, C 25 ohms, and D 250 ohms. So we're asked to find the resistance of the galvanometer. Now, this is a conversion of galvanometer to a voltmeter, and like we know, a galvanometer is an instrument that is used to measure very, very small currents. Now, it is given that the current that is being measured with full scale deflection, I, is equals to 0.005 watts amperes. Now, this galvanometer is converted to a voltmeter reading up to 5 volts. That means the total voltage V is equals to what? 5 volts, using an external resistance of 975 ohms. Now, in the conversion of a galvanometer to a voltmeter, a multiplier, which is an external resistance, is actually what applied, and that's resistance is known as what? R2, and this is R2 is equals to 975 ohms. Now, the initial what resistance, or the internal resistance of the galvanometer, is known as R1, which is what we are asked to look for. Now, each of these resistance has its own voltage, which sum up to give us this total voltage V. So therefore, we have V1 and we also have V2. So we have V1, which is not known, and also V2, which is not known. Now, V2 is the resistance of the what is the voltage of this external resistance, while V1 is the voltage of the what of the galvanometer, that is the internal resistance. Now, let's find V2. V2 is equal to I times R2, and this is equal to 0.005 multiplied by 975, and this is equal to 4.875 voltage V. So from this we can say what V, which is the total voltage, is equals to V1 plus V2. Now, since we have V, which is 5 voltage, and V2, which is 4.87 voltage, we can find what V1, and V1 is equals to what V minus V2, which is equals to 5 minus 4.875, and this is equal to 0.125 voltage. So V1 is equal to 0.125 volts. Now, since we have V1 now to be equal to 0.125 volts, we can now find what? We can now find R1, because R1 is resistance of the galvanometer. From V is equals to I times R1, that's V1 is equals to I times R1, we say R1 is equals to V1 all over I, and this is equals to 0.125 all over 0.005, and this is equals to 25 ohms. So 25 ohms is the resistance of the galvanometer, and that is option C. Thank you and God bless you. Ensure to subscribe to the channel for more videos. Hello, good day and welcome. I will be answering Wassce 2020 physics past question 20. A beam consisting of alpha particle, beta particle, and gamma rays pass through a magnetic field at right angles to the direction of the field. Which of the following observations were made about the alpha particle, beta particle, and gamma rays respectively? A. Deflected, deflected, and deflected, meaning that the alpha ray will be deflected, beta ray will be deflected, and the gamma rays will be deflected. B says deflected, deflected, not deflected. C, deflected, not deflected, deflected, and D, not deflected, deflected, and deflected. Now, this respectively here simply means that what each of these options, like this first deflected here, stands for the alpha particle, this stands for the beta particle, and D stands for the what gamma rays. So that's what it means. Now, the question says a beam consisting of alpha particle, beta particle, and what gamma rays pass through a magnetic field at right angle to the direction of the field. Now, let's take for instance, we have a magnet, a bar magnet. This is a bar magnet producing the what magnetic field, and this is the north pole, and this is the south pole, and we have what a radiation consisting of these three what particles, that is the alpha particle, the gamma particle, the beta particle, and the gamma rays. Like this, we have a reactive element producing what these rays or these particles. Now, I want you to understand that the alpha particle is what positively charged. Alpha particle has a positive charge. Now the beta particle has a negative charge. It's negatively charged. While the gamma rays is neutral. The gamma ray is neutral. It has no charge at all. Now, like we know, when a positively charged particle goes into a magnetic field, it will be deflected towards the south pole. Likewise, when the negatively charged particle goes into a magnetic field, it will be deflected towards the north pole. So therefore, because of this, we'll have that the alpha particle will be deflected towards the beta particle. Sorry, since it's negatively charged, will be deflected towards the north pole. Now this is the beta particle. It's negatively charged, so it's deflected towards the north pole. Now the alpha particle, since it's positively charged, will be deflected towards the south pole. It is positively charged. Now the gamma rays, which has no charge, will be neutral, will not be deflected. So you can see now that the alpha particle will be deflected, the beta particle will be deflected, but the gamma rays will not be deflected. And this is option B. This is option B. It says gamma particle, alpha particle deflected, beta particle deflected, and gamma rays not deflected, because the gamma rays is neutral, it has no charge. So therefore the answer to this question is option B. Thank you and God bless you, and subscribe to the channel for more videos. Good day and welcome. I will be answering Wassce 2020 Physics Past Question 21. A parallel plate capacitor is charged and the charging battery subsequently disconnected. If the plates of the capacitor are moved further apart by means of insulating handles known as the dielectric substance, the dash A, capacitance would increase, B, capacitance would decrease, C, charge on the capacitor would increase, and D, charge on the capacitor would decrease. Now, like we know, the capacitance of a capacitor is inversely proportional to the distance between the plates. That is to say that the capacitance C is inversely proportional to the distance between the plates, and this is derived from the formula C is equals to permissivity of free space multiplied by the area all over the distance. Now this D here stands for the distance between the plates of a parallel plate capacitor, and like you can see, you see that capacitance is inversely proportional to this distance. So therefore, increasing the distance between the plates of this capacitor will lead towards a decrease in capacitance, and vice versa. Now the question says, if the plates of the capacitor are moved further apart, simply that's meaning that if this is a plate and this is a plate and this is distance between them, now if these two plates are moved further, that they are moved further apart, now you see that the distance D has increased, and increasing this distance between the plates will lead towards a decrease in the capacitance of this capacitor, and that is option B. The capacitance will decrease. So option B is the answer to this question. Thank you and God bless you. Ensure you subscribe to the channel for more videos. Hello, good day and welcome. I will be answering Wassce 2020 Physics Past Question 22. The velocity of sound in air at 15 degrees Celsius is 340 meters per second. Calculate the velocity at 47 degrees Celsius. A 790 meter per second, B 602 meter per second, C 358 meter per second, and D 322 meter per second. Now the relationship between the velocity of sound in air and temperature is given as V1 is equal to, or V1 over V2 is equal to square root of theta 1 all over square root of theta 2. This theta here represents the temperature. That is, the velocity of sound in air is directly proportional to the square root of the temperature. Now we're given that V1 is 340 meter per second and V2 is what we are looking for, the unknown. Now the initial temperature is 15 degree Celsius and the final temperature, that's theta 2, is equal to 47 degrees Celsius. Then we're asked to find the velocity at this 47 degrees Celsius. So therefore we have that V1, which is 340 all over V2, which is the unknown, is equal to the square root of 15 all over square root of 47. Now from this we can say V2 is equal to 340 multiplied by the square root of 47 all over square root of 15, and calculating this we have that V2 is equal to, or approximately, 602 meter per second. 602 meter per second, and that is option B. Thank you and God bless you, and subscribe to our channel for more videos. Hello, good day and welcome. I will be answering Wassce 2020 Physics Past Question 23. Which of the current voltage characteristics shown below is exhibited by an ohmic conductor? Which of the current voltage characteristics shown below is exhibited by an ohmic conductor? Now we're given the following graphs, and we have to pick what's one of the graphs that exhibits the characteristics of a current voltage of an ohmic conductor. Now an ohmic conductor is simply a conductor that obeys Ohm's law. A conductor which obeys Ohm's law. It obeys Ohm's law. And like we know, Ohm's law states that the current flowing through a metallic conductor, that is like wire or a metal, is directly proportional to the potential difference across the ends, provided that temperature and pressure are kept constant. Now it says that the current flowing through a metallic conductor is directly proportional to to a potential difference, that's the voltage. Now this is Ohm's law, and so therefore we have that V over I is equal to constant, and so therefore we say V over I is equal to the resistance. Now this is Ohm's law. Now in the graph, now we are given a graph of current against voltage, meaning I against against V, and now this is the inverse of this is the inverse of resistance. We can call it resistance inverse. Now this I over V will still carry the same relationship as V over I, which is equals to resistance. Now I over V is just like just changing it, like finding the reciprocal of R, but that relationship will still be will still be maintained. That is, that direct relationship will be maintained, because it is seen that the current from Ohm's law is directly proportional to the voltage. So therefore increase in current will lead to an increase in voltage. An increase in voltage will lead to increase in current. And so therefore the graph that can be represented as this will be given like this. If you have the current I against voltage, now since they are directly proportional to each other, whenever there's an increase in current, there will also be an increase in voltage, and this is option B. So option B is the correct illustration of the characteristics of a current voltage exhibited by an ohmic conductor. So option B is the correct answer to this question. Thank you, and sure to subscribe to our channel for more videos. Hello, good day and welcome. I will be answering Wassce 2020 Physics Past Question, question 24. A 500 Newton box rests on a horizontal floor. A constant horizontal force is exerted on the box so that it moves through 8 meters. If the coefficient of kinetic friction between the floor and the box is 0.22, calculate the work done on the box. A. 880 joules, B. 440 joules, C. 400 joules, and D. 110 joules. So we are asked to find what the work done. That is the work done in moving this box through a distance of 8 meters. Now for us to find the work done, we have to find the force. Now the question says a 500 Newton box. Now this is the weight of the box, that is the reaction acting on this box, which is the weight. Now let's assume this is the horizontal floor, and then the box is lying on this horizontal floor. Let's assume this is the box, and the weight of the box, that is the force acting downward on the weight of the box, is what is 500 Newton. That is R, the reaction acting on the box, is 500 what Newton. Now a constant horizontal force F, a constant horizontal force, let's call this force F, that is required to move this box against what friction, is applied to move the box through 8 meters. So the distance D is equal to 8 meters. Now if the coefficient of kinetic friction, is called mu, is equal to 0.22. Now calculate the work done on the box, and like we know that what work, W, is equals to force times distance. Now we have distance but we don't have force. Now to find our force, there's a formula that's connecting the coefficient of kinetic friction with force and reaction, and this formula says that the coefficient of kinetic friction, mu, is equal to force all over reaction, which is the same as the weight of the box. And so we have that mu is 0.22, so we say 0.22 is equal to F all over 500. So F is equals to 500 multiplied by 0.22, and F is equal to 110 Newton. 110 Newton. So this is the horizontal force. Now to find the work done, W, is equals to force times distance, and this is equal to 110 Newton multiplied by 8, and W, the work done, is equals to 880 joules, and that is option A. So the work done is 880 joules. Thank you and God bless you, and sure to subscribe to our channel for more videos. Hello, good day and welcome. I will be answering Wassce 2020 Physics Past Question, question 25. A diagram above, that is this diagram above, illustrates a ball of mass m sliding down a plank inclined at an angle theta to the horizontal. The kinetic friction between the ball and the plank is F, which is shown, and the acceleration of free fall is G, that's acceleration due to gravity. The normal force on the ball is A, mg sin theta, B, mg tan theta, C, mg cos theta, and D, mg cot theta. So we're given an inclined plane. Let's draw our inclined plane. We're given an inclined plane, and then a ball is illustrated on this inclined plane. Let's assume this is a ball. Now there's a force acting on this ball. We call this force what? The frictional force, which is given as F, that's the kinetic friction. Now there are various forces acting on this. First of all, we have the what? We have the net force. Let's call this Ft, acting here. Also, we have what? We have the normal reaction, that is the normal force. We have the normal reaction, that's the vertical component. Now this vertical component, let's call it Fn, that is normal reaction, normal force, is acting what? Downward and upward. This is the normal reaction. Then also now we now have the what? The weights acting downward also, and the weight is what? Giving us mg. And remember, it is inclined to what? Angle theta. Now, to find the normal reaction or the normal force, this is the normal force Fn. The normal force is what? Is the horizontal component acting, that is the horizontal component of the force acting on this what? On this ball, on this inclined plane. And this horizontal component is giving us mg, that is the weight of this ball multiplied by what? Cos theta. But for the horizontal component, which is ft, it is giving us mg sine theta. This is the horizontal component, and the normal force is the what? Is the vertical component, which is mg cos theta. So Fn is the what? Is normal force acting on the ball, and that is option C. Mg cos theta is the answer to this question. Thank you and God bless you. And subscribe to the channel for more videos. Hello, good day and welcome. I will be answering Wassce 2020 Physics Past Question, question 27. What factors determine the frequency of a note emitted by vibrating string? A. The amplitude of vibration, force constant of string and length of string. B. Amplitude of vibration, force constant of string and tension in string. C. Mass per unit length of string, tension in string and length of string. And D. Force constant of string, tension in string and length of string. So the question says what factors determine the frequency of a note emitted by vibrating string. Now the frequency of a note emitted by vibrating string F is giving us 1 all over 2L, that's 2 times length, multiplied by the square root of the tension in the string all over the mass per unit length. Now this is the formula for finding the frequency of a note emitted by a vibrating string. Now from here you will see that this frequency actually depends on it depends 1 on the length of the string, 2 the tension in the string, which is the T. The length of the string is L, tension of the string is T, and also the mass per unit length, which is which is M. The mass per unit length, and this is M. And this is the formula for finding the frequency of a note emitted by a vibrating string. This is the L, this is the tension, and this is the mass per unit length. So we have that F frequency is equal to 1 all over 2L multiplied by the square root of the tension all over the mass per unit length. Now from this you agree with me that option C is the correct answer to this question, because option C says mass per unit length, which is this, tension in string, which is this, and length of string, which is this. So the correct answer to this question is option C. Thank you and God bless you. Ensure to subscribe to our channel for more videos. Hello, good day and welcome. I will be answering Wassce 2020 Physics Past Question, question 28. The magnitude of the force experienced by a charge of 1.6 times 10⁻⁻8 Coulomb in a uniform electric field of intensity 5 times 10⁻⁵ Newton per Coulomb is A. 3.2 times 10⁻⁻14 Newton, B. 8.0 times 10⁻⁻3 Newton, C. 8.0 times 10⁻³ Newton, and D. 3.1 times 10⁻13 Newton. So we have to find the magnitude of the force that is experienced by a charge in a uniform electric field of intensity 5 times 10⁻⁵ Newton per Coulomb. Now electric field intensity E is giving us the force experienced by a charge all over the quantity of this charge, Q. So this is the force, this is the quantity of charge, and this is the electric field what intensity. Now we are given what E to be equal to 5 times 10 raised to the power of 5 Newton per Coulomb, and Q, the quantity of charge, to be equal to 1.6 times 10 raised to the power of minus 8 Coulomb. Now we are asked to find what the force experienced by this charge. So therefore from this formula here, we can say F is equal to the electric field intensity multiplied by the quantity of charge. And so F is equals to 5 times 10 raised to the power of 5 multiplied by 1.6 times 10 raised to the power of minus 8. So we have that F is equals to 5 times 1.6 multiplied by 10 raised to the power of 5 minus 8. And so F is equal to 8.0 multiplied by 10 raised to the power of minus 3 Newton. And that is option B. Option B, 8.0 times 10 raised to the power of minus 3 Newton. So this is the answer to this question. This is the force experienced by the charge in this uniform what electric field. Thank you and God bless you, and subscribe to our channel for more videos. Hello, good day and welcome. I will be answering Wassce 2020 physics past question 29. Which of the following statements about viscosity is not true? It's A, depends on the area of the surface in contact. B, occurs in fluids. C, is independent of relative velocity of the layers. And D, depends on the tangential force between the layers. So we have to pick a statement which is not true about viscosity. Now, what is viscosity? Viscosity simply refers to viscosity is the internal friction between layers. The internal friction between layers of liquid or gas in motion. So viscosity is also what? A frictional force. But now viscosity is a frictional force in what? In fluid. It is a what? Is a force that acts in fluid. That's why you call it the internal friction between what? Layers of liquid or gas. And like we know, liquid or gases constitute what? Are fluids. Now option A says viscosity depends on the area of the surface in contact. Yes, unlike frictional force do not depend on the area of the surface in contact, but viscosity actually what depends on the area of the what of these fluids. It depends on the area of the surface in contact, that is the layers in contact. The areas of these layers in contact is actually what's important in terms of viscosity, and it occurs in fluids, making option B valid. Then C says it's independent of the relative velocity of the layers. Now this is wrong. Viscosity actually what depends on the relative velocity between the layers in contact. That is, the layers of these fluids in contact is actually what is actually important in terms of viscosity, because their relative velocity actually affects viscosity. So viscosity depends on the relative velocity of layers. Now let me explain this. If you have a viscous fluid like your engine oil now, and you put a stone inside this engine oil, you discover that this stone will be going down gradually, little by little. It won't be as when you put a stone inside a less viscous fluid like water. Now this stone moving downward is experiencing viscosity, and now its velocity is relative to the velocity of the layers of this fluid, and so therefore viscosity depends on the relative velocity of the layers in contact. So option D says depends on the tangential force between the layers. Yes, it also depends on the tangential force between the layers. Now from this you see that the only false option here is option C, which is not true. and this makes our option C the answer to this question, because the question says which of the following statements about viscosity is not true, and option C is not true because viscosity is dependent of the relative velocity of the layers. Thank you and God bless you, and just subscribe to the channel for more videos. Good day and welcome. I will be answering Wassce 2020 physics past question 30. A motorcycle starting from rest is uniformly accelerated such that its velocity in 10 seconds is 72 km per hour. What is its acceleration? A. 108 meter per second, B. 86 meter per second square, C. 4 meter per second square, and D. 2 meters per second square. So we are asked to find the acceleration, and the question says the motorcycle starts from rest and it's uniformly accelerated, such that its velocity in 10 seconds is 72 kilometers per hour. Now we're given that it's start from rest, meaning the initial velocity u is equal to 0. Then it's accelerated uniformly to such that it attained a final velocity of 72 km per hour. So v final velocity is equals to 72 km per hour. Now the time taken c is equal to 10 seconds. Now we are asked to find the acceleration, and now we know that acceleration is equal to final velocity v minus initial velocity u all over the time taken. But now if you look at our options here, our options are given in meter per second, but the velocity given to us here is given to us in kilometer per hour, and also the time given to us is in seconds. So therefore we have to convert this our final velocity from kilometer per hour to meter per second, and in doing this we say v is equals to 72. Since 1000 meters will give 1 kilometer, we say times 1000 all over. Now per hour we have that per hour we have 60 minutes, and in a minute we have 60 seconds. So we say all over 60 times 60, and this is equals to 72,000 all over 3600. And from here we have that v final velocity is equal to 20 meter per second. Now we've gotten our final velocity in meter per second. Now we can continue. So we have that a acceleration is equals to v minus u all over t, and this is equals to final velocity 20 minus initial velocity 0 all over time taken 10. So therefore a is equals to 20 all over 10, and this is equals to 2 meter per second square. So 2 meter per second square is the acceleration, and that is option D. Thank you and God bless you, and just subscribe to the channel for more videos. Hello, good day and welcome. I will be answering Wassce 2020 physics past question 31. The temperature of an object is raised by 120 degrees Celsius. The resulting increase in its absolute temperature is A. 50 Kelvin, B. 120 Kelvin, C. 200 Kelvin, and D. 393 Kelvin. Now, absolute temperature T is given in terms of Kelvin, and this is expressed as 273 plus the value in degree Celsius. Now we are given a temperature rise of 120 degrees Celsius. So therefore the absolute temperature T, which is given in Kelvin, will be equal to 273 plus 120, and the temperature T is equal to 393 Kelvin. So this is the absolute temperature for the increase by 120 degrees Celsius. But now it is given in Kelvin, and that is 393 Kelvin, which is option D. So this is the answer to the question. Thank you and God bless you, and subscribe to the channel for more videos. Hello, good day and welcome. I will be answering Wassce 2020 Physics Past Question, question 32. Which of the following statements about the motion of a simple pendulum is true? A. It is a simple harmonic motion when the angle of displacement is large. B. It passes the equilibrium position with minimum speed. C. It possesses maximum kinetic energy at the extreme position. And D. It swings faster at the pole than at the equator. So we are asked what? To pick an option which is true about the motion of a simple pendulum. Now I want you to know that a simple pendulum actually exhibits what? A simple harmonic motion. It exhibits a simple harmonic motion, that's SHM. Now it's this simple harmonic motion is actually what? As a result of any displacement of what? This simple pendulum. It mustn't be what? A large what? Angle of displacement. The angle of displacement can either be large or small, but once a pendulum is displaced by any angle, it exhibits what? It exhibits a simple harmonic motion for it to return to its what? Equilibrium position. A simple pendulum do not return to its equilibrium position at once. It undergoes what? A simple harmonic motion. That is a to and fro motion before it's what? Before it finally what? Gets to its equilibrium position. Now let me represent this motion diagrammatically. Let's say for instance we have a simple pendulum suspended like this. Now when displaced, it will have an extreme position here and likewise an extreme position here. Now let me describe the motion like this. So this is the diagrammatic representation. Now this is the what? Equilibrium position of this pendulum. Now when it is displaced, it undergoes what? A to and fro movement, a simple harmonic what? Motion. Now at this point, the potential energy PE is what? Is maximum. The potential energy here is what? Maximum, and the kinetic energy is 0 at this point. Why? This is because the velocity at this point V is 0, and likewise the same with this point. But at this point, while in the what? In motion, at this equilibrium point, the kinetic energy here Ke is what? Is maximum at this point, and the what? Velocity here is minimum. So therefore a simple pendulum, when approaching the what? Its equilibrium position, it approaches it with a what? With a minimum velocity, that is a minimum speed. And at this equilibrium point, the potential energy PE is what? Is 0. PE is 0. Now let's look at the questions, the options. A says it is a simple harmonic motion when the angle of displacement is large. No, it is wrong. It's a simple harmonic motion irrespective of what? The angle of our displacement. Now B says it passes the equilibrium position with minimum speed. Yes, this is correct. Like what I described earlier, I said at this equilibrium position kinetic energy is maximum, and while approaching the what? The equilibrium position, it passes it what? With minimum speed. Now C says it possesses maximum kinetic energy at the extreme position. No, this is the extreme position, and like I told you, I said at this extreme position the velocity is 0, so therefore kinetic energy is 0, but the potential energy here is what? Maximum. So this is wrong. And this says it swings faster at the pole than at the equator. No, at the pole what? The velocity is 0, but at the equator here, the equilibrium position, the velocity is what? Is minimum. So it is also wrong. Now the only true answer here is option B. It passes the equilibrium position with minimum speed, and this is the answer to this question, option B. Thank you and God bless you. Ensure to subscribe to our channel. Hello, good day and welcome. I will be answering Wassce 2020 Physics Past Question, question 34. Which of the following statements about photoelectrons is correct? A. A faint green light produces photoelectrons with less kinetic energy than a bright red light. B. A red light releases a smaller number of electrons than a green light. C. A faint green light produces photoelectrons with greater kinetic energy than a bright red light. And D. A red light produces more photoelectrons than a green light. Okay, now photoelectrons, first of all let's explain what photoelectrons simply means. Photoelectrons are emitted electrons. They are electrons which are emitted when light ray hits a metal surface or hits metallic surface. Now what these emitted electrons are called the photoelectrons, and this phenomenon is now called the photoelectric emission. That's photoelectricity, and has been applied in our various life. Now photoelectrons are actually what emitted electrons, and these photoelectrons has kinetic energy. The kinetic energy of photoelectrons, that is the kinetic energy of emitted electrons, the kinetic energy Ke, is independent, that is do not depend on the intensity of the incident light. Do not depend on the intensity of the incident light. And if you look at option A says a faint green light. Now this is talking about the intensity. Produces photoelectron with less kinetic energy than a bright light, red light. Now this option is already invalid, because they are talking about intensity here, faint green light and bright red light, and kinetic energy do not depend on intensity. Kinetic energy Ke only depends on frequency of the incident light or the wavelength of the incident light. Now B says a red light releases a small number of electrons than a green light. Now the intensity of the incident light only affects the number of electrons that are emitted. Now, like we know, a red light has a higher intensity than a green light, and so therefore a red light is expected to give higher number of electrons than a green light. So therefore rendering this option invalid. A red light will give it will give a higher number of electrons than a green light. So this option is wrong. Now C says a faint green light produces photoelectrons with greater kinetic energy than a bright red light. Now I said already that kinetic energy of these photoelectrons do not depend on the intensity at all. Now this is a red light produces more photoelectrons than a green light. Yes, a red light which has higher wavelength, higher frequency, and higher speed or velocity or intensity than the green light will produce more photoelectrons than the green light. So therefore option D is valid and is the correct answer to this question. Thank you and God bless you. Ensure subscribe to our channel for more videos. Hello, good day and welcome. I will be answering Wassce 2020 Physics Past question 35. The sketched graph above illustrates the heating curve of 0.02 kilogram of water. Determine the approximate value of the specific latent heat of vaporization of water. A. 2.25 times 10 raised to the power of 6 joule per kilogram. B. 4.17 times 10 raised to the power of 3 joule per kilogram. C. 2.00 times 10 raised to the power of 3 joule per kilogram. And D. 1.00 times 10 raised to the power of 3 joule per kilogram. Now, we are asked to find the specific latent heat of vaporization. Now, specific latent heat of vaporization is simply defined as the quantity of heat required to change unit mass of a substance from its liquid at boiling point to vapor without a change in temperature. Now the question is telling us about the heating curve of water, and like we know, the boiling point of water is 100 degrees Celsius. So that means when we are to calculate our specific latent heat of vaporization, we'll consider the temperature at 100 degrees Celsius, whereby the entire liquid has been converted to vapor, and this is the point where the entire liquid has been converted to vapor, and the corresponding heat applied in joules is 53. The heat H is 53 times 10 raised to the power of 3 joules. Now the mass given to us is 0.02 kilogram, and our specific latent heat of vaporization is given as L. Now L is given as H all over M. This is derived from the formula heat is equal to mass times specific latent heat of vaporization. So we now have that specific latent heat of vaporization L is equals to the heat all over the mass given, and this is equal to 53 times 10 raised to the power of 3, which is 53,000 all over 0.02, and this is equal to 2.25 times 10 raised to the power of 6 joule per kilogram, and this is option A. So option A is the correct answer to this question. So this is the specific latent heat of vaporization of water. Thank you and God bless you, and subscribe to the channel for more videos. Hello, good day and welcome. I will be answering Wassce 2020 Physics Past Question, question 36. In a hydraulic press, the force F applied is related to the diameter of the cylinder by A. F is directly proportional to the square of the diameter. B. F is directly proportional to the diameter. D. C. The force F is inversely proportional to the diameter. And D. The force F is inversely proportional to the square of the diameter. Now, in a hydraulic press, the Pascal principle is applied. In a hydraulic press, the Pascal principle is applied, and in this Pascal principle, the force F is directly proportional to the area. The force F is directly proportional to the area of the cylinder or the area of the container. Now let's take, for instance, you have something like this. Now this is a bigger cylinder and a smaller cylinder with piston like this. Let's assume this is a piston, and this is also a bigger cylinder with its piston. Now you see that the force that will be applied here is directly proportional to the area of this cylinder. That is, the force here, now when force is applied here, because of the larger area of this cylinder here, the force here will increase. Now this is a typical example of a hydraulic press. Now, since we know that the area of this cylinder is as a result of its radius, and its radius can be used to get the diameter, we can also say that that the force of this hydraulic press is directly proportional to the diameter of this cylinder, because the more the cylinder, the more the diameter of the cylinder, the greater the radius, and likewise the greater the area, and the greater the area, the greater the force. So therefore, the force in a hydraulic press is directly proportional to the diameter of the cylinder of this hydraulic press, and that is option B. So option B is the answer to this question. Thank you and God bless you, and subscribe to our channel for more videos. Hello, good day and welcome. I will be answering Wassce 2020 Physics Past Question, question 37. In an electric circuit, an inductor, inductance 0.5 Henry, and resistance 50 ohms is connected to an alternating current source of frequency 60 Hz. Calculate the impedance of the circuit. A 50 ohms, B 150.5 ohms, C 195.0 ohms, and D 1950.1 ohms. So we're asked to find the impedance of this circuit. And like we know, impedance is the total opposition to the flow of current offered by the inductor, the resistor, and the capacitor. But in this circuit, the capacitor is not involved. So we have to find the impedance involving the inductor and the resistor. So the inductor has an inductance of 0.5 Henry and the resistance of 50 ohms. Now, the formula to find the impedance Z is equal to the square root of R square, that's the resistance square, plus the square of of the inductive reactance, XL, the square of inductive reactance. Now we have R to be equal to 50 ohms. Then XL, inductive reactance, is not known, and inductive reactance XL is equal to 2 pi FL. Now this L here is the inductance, F here is the frequency. So we can say XL, inductive reactance, is equals to 2 multiplied by 22 all over 7, which is the pi, times the frequency 60 multiplied by the inductance 0.5. Now from this we have that the inductive reactance XL is equal to 1320 all over 7, and this is equals to 188.6 ohms. So this is the inductive reactance. So we can now solve for the impedance, which is equal to the square root of R square, that's 50 square, plus 188.6 square. Now when you do this with your calculator, you have that the impedance Z is equals to 195.0 ohms. So this is the impedance for this AC circuit, and this is option C, 195.0 ohms. Thank you and God bless you. Ensure to subscribe to our channel for more videos. Hello, good day and welcome. I'll be answering Wassce 2020 Physics Past Question, question 38. Which of the following statements correctly explains why a total solar eclipse would be seen by people on only a small portion of the Earth's surface? A. Moon is larger in diameter than the Earth. B. Earth is larger in diameter than the Moon. C. Earth revolves around the Sun. And D. Earth is larger in diameter than the Moon. Now, eclipse simply occurs when the moon, the sun, and the earth are on a straight line. We say an eclipse has occurred. Now we have the solar eclipse and the lunar eclipse, but the question here is concerned with the solar eclipse. Now an eclipse can either be total or partial. It is either total or partial eclipse. Now the question is asking us about a total solar eclipse. Now in a solar eclipse, the moon stays between the sun and the earth. Let's say for instance you have the sun. This is the sun. Now you have the moon, and then you have the earth. Now this is the earth. You will see that only a small portion of the earth will be affected by the total solar eclipse, because the moon here will be blocking the rays of light from the sun to this particular part of the earth. But other parts of the earth, like this part and this part, we experience partial solar eclipse. But this part here we're experiencing a total solar eclipse. Now the question is asking us that why is it that just a small portion of the earth experienced total solar eclipse? Now if you look at it, you notice that what the diameter of the moon is smaller compared to the diameter of the earth, and that is why only a small portion of the earth is affected by what a total solar eclipse. The diameter of the earth is equal to 12,756 kilometer approximately, and the diameter of moon is equal to 3,476 kilometer approximately. Now you will see that what the diameter of the moon is smaller compared to the diameter of the earth, and that is why a total solar eclipse only affects what a smaller portion of the earth's surface, because the moon is not as big as the earth. Now the answer to this question, from what I just explained, is option D. Earth is larger in diameter than the moon. And this is the answer to the question, because in a solar eclipse the moon stands between the sun and the earth, and because of the larger diameter of the earth than the moon, we say that only a small portion of the earth is actually affected by this total solar eclipse, but the other parts might experience a partial solar eclipse or no eclipse at all. So option D is the answer to this question. Thank you and God bless you. Ensure to subscribe to the channel for more videos. Good day and welcome. I will be answering Wassce 2020 Physics Past Question, question 39. Water waves have a wavelength of 3.6 cm and speed of 18 cm per second in deep water. If the waves enter shallow water with wavelength of 2.0 cm, calculate the speed of the wave in the shallow water. A 0.4 cm per second, B 2.5 cm per second, C 10 cm per second, and D 10.8 cm per second. So we're given that a water wave has a wavelength of 3.6 cm and speed of 18 cm per second in deep water. So in deep water, we have that the velocity, that's the speed of the wave, is equal to 18 centimeter per second. We have that the wavelength lambda is equal to 3.6 centimeter. Now we know that the frequency of a wave is always constant, irrespective of where this wave is going. So that is, the frequency of a water wave is always constant. So now for us to find the speed of the wave in the shallow water, we have to find the frequency first, and we can only find the frequency using the parameters of the wavelength and the speed in the deep water. And we know that V is equal to F lambda. Now F, frequency, is equal to V all over lambda, that is the velocity or the speed of the water wave all over the wavelength. So we therefore have that F, frequency, is equal to 18 all over 3.6, and this is equal to 5 hertz, or you can call it per second. So we've gotten the frequency. Now in shallow water, since we know that the frequency is always the frequency of the wave remains the same, it is constant, we have that the frequency F in shallow water is equal to 5 hertz. Also we have that the wavelength now lambda in shallow water is 2.0 centimeter. Now we are asked to find the speed of the wave in shallow water, that is V is equal to F lambda, and this is equal to 5 multiplied by 2, which is equal to 10 centimeter per second. So 10 centimeter per second is the speed of the wave in the shallow water, and that is option C. Option C is the answer. Thank you and God bless you. Ensure to subscribe to our channel for more videos. Good day and welcome. I will be answering Wassce 2020 Physics Past Question, question 40. An AC generator can be converted into a DC electric motor by replacing the A. slip rings with a split ring and connecting a battery, B. Split ring with a slip ring and connecting a battery. C. AC with DC source and connecting slip rings. And D. AC with DC source and connecting split rings. So the question is asking us that for an AC generator to be converted to a DC electric motor, the following things has to be put in place. Now, an electric motor is an electric device that converts electrical energy into mechanical energy. That's an electric motor. Now this electric motor has various parts. One of the parts which is very important is the armature. It has an armature. It has a powerful magnet that produces the powerful magnetic field. A commutator consisting of split rings, and then it has two carbon brushes. Now, an AC generator, alternating current generator, is a device that converts mechanical energy into electrical energy, just the opposite of a DC electric motor. Now this AC generator has what we call the slip rings. It consists of the slip rings. Now in converting an AC generator to a DC electric motor, these slip rings has to be replaced with a split ring. Remember I said an electric motor is made up of split rings. That is, the commutator of an electric motor is made up of split rings. So therefore you have to replace these slip rings with the split rings. This is the only difference between this generator and the electric motor, and also replacing the alternating current with a direct current. That is, replacing the AC current with a direct current. So these are the two major things required for the conversion of a AC generator to an electric motor. So therefore the answer to this question is option D. That is, the AC source will be replaced with a DC source, and then the slip rings will be replaced with with a split ring, which is the component of an electric motor. So option D is the answer to this question. Thank you and God bless you. Ensure to subscribe to the channel for more videos. Hello, good day and welcome. I will be answering Wassce 2020 Physics Past Question 41. A ray of light travels obliquely from a less dense medium to a denser medium. Which of the following statement is true about the light? A. The wavelength of the light increases in the second medium. B. The speed of the light increases in the second medium. C. The light refracts towards the normal. And D. There is a change in the frequency of the light. Now, when a ray of light travels from a less dense medium, let's assume the less dense medium is air, and then the denser medium is glass. So we'll have something like this. Let's assume this is our rectangular glass block. Now this is air and this is glass, the denser medium. Now let's assume we have a normal ray. Let's call this a normal ray, and a ray of light passes obliquely from the less dense medium, which is the air, to the denser medium, which is the glass. Now it will be observed that this ray here is known as the incident ray. We call it the incident ray, and this angle is the angle of incidence. Now as this ray of light passes from a less dense medium, which is the air, to a denser medium, which is glass, this ray of light will bend towards the normal. It will bend towards the normal, so that the angle will be lower than the angle of incidence. Now this phenomenon is what we call refraction. Refraction occurs when light rays bend, that is, change in direction of the ray of light as it's passing different media of different densities. Now it is said that this light ray has been what has been refracted towards the normal, and we call this the refracted ray. And this angle, we call it the angle of refraction. Angle of refraction. Now if it was that the ray of light was traveling from a denser medium, which is the glass, to a less dense medium, now it will move far away from the normal. That is, the ray will move away from the normal. But because it is moving from a less dense medium to a denser medium, it is moving towards the normal. That means the ray of light has been refracted because there is a change in density of the medium. Now the wavelength won't be affected, the speed won't be affected, neither will the frequency be affected, but the direction of this wave will be affected, and that is refraction. And the ray of light, because it is moving from a less dense to a denser medium, it will move, the ray of light will move or will be refracted towards the normal ray. And this is the normal ray, and that is why the angle of refraction is lower than the angle of incidence when ray of light moves from a less dense medium to a denser medium. So the answer to this question is option C. The light refracts towards the normal. That's the answer to this question. Thank you, and sure to subscribe to our channel for more videos. Hello, good day and welcome. I will be answering Wassce 2020 Physics Past question 43. Which of the following statements about the process of melting of a solid are true? The temperature of the solid will 1. Remain steady until melting starts. 2. Keep rising until melting starts. 3. Remain steady as melting proceeds. 4. Keep rising as melting proceeds. And that is it. Now option A says 2 and 3 are correct. Option B says 3 and 4 only are correct. Option C says 1, 2 and 3 only is correct, and option D says 2, 3 and 4 only is correct. Now, when heat is applied to a solid, certain changes occur, but before these changes occur, there must be an increase in temperature in this solid. Now let's represent this graphically using a graph. Let's assume this is the temperature and here is the time in minutes, and this is what temperature in degrees Celsius. Now let's assume heat is applied to a solid. Now when heat is applied to a solid, this heat in the solid will continue, the temperature of the solid will continue to increase until it gets to a point, the melting point of this solid, where this solid begins to melt into liquid. Now this melting point, let's call it the melting point. At this melting point, the temperature do not increase. The temperature remains the same. It remains uniform until the entire solid has changed to liquid, and then the temperature again begins to increase. The temperature then begins to increase. So at this point, we call this point the melting. We call it the melting process, because at this point, this is where the solid changes to liquid, so it is a melting process. And at this point, the temperature remains constant, it does not change. But before it reaches the melting point, what happens? The temperature increases. So when heat is applied to a solid, temperature increases. The temperature increases until the solid begins to melt. Now at this melting point, that is when the melting starts, the temperature remains constant. It remains steady. So during melting process, temperature remains steady. Now from this, you see that statement 2 is correct, that is keep rising until melting starts. It keeps rising until the melting starts. So statement 2 is correct. Now statement 3 says remain steady as melting proceeds, which is also correct. It remains steady as the melting proceeds. Now 1 says remain steady until melting starts, it is wrong, and 4 says keep rising as melting proceeds, which is wrong. So the answer to this question is option what? Option A is the answer to this question. That is, statements 2 and 3 only are correct. Thank you, and ensure to subscribe to our channel for more videos. Hello, good day and welcome. I will be answering Wassce 2020 Physics Past Question, question 44. A diver steps off a diving platform that is 10 meters above the water. If there is no air resistance during the fall, there will be a decrease in the diver's A. Gravitational potential energy, B. Total mechanical energy, C. Kinetic energy, and D. Momentum. So let's assume the level of the water is the ground level. Let's assume that is the ground level. Now when a diver dives from a platform, it is expected that due to gravity the driver will fall. Now during this fall, the height of the driver decreases. The height decreases. Now since the height decreases, we must look for a term or a concept here that is also affected when height decreases. And like we know, option A, which is gravitational potential energy, which is described as the work done in raising a mass m from ground level or from ground surface or from the ground to a level or to a height above the ground. Now this gravitational potential energy depends on height. The gravitational potential energy depends on height, meaning that gravitational potential energy is directly proportional to height. And this can be seen from the expression gravitational potential energy is given as mgh. So now when this diver dives and begins to fall, during this fall, height decreases, like I said, and due to the decrease in the height, there will be a decrease in the gravitational potential energy, because gravitational potential energy is directly proportional to the height. Like I told you, I say it depends on height. So due to the decrease in height, there will be a decrease in gravitational potential energy, and that is option A, which is the answer to this question. Thank you, and just subscribe to our channel for more videos. Hello, good day and welcome. I will be answering Wassce 2020 Physics Past Question, question 45. Which of the following actions would increase the electric force between two positively charged particles? A. Decreasing the mass of the particles. B. Decreasing the distance between the particles. C. Increasing the distance between the particles. And D. Increasing the mass of the particles. Now, according to Coulomb's law, we state that the electric force between two electrons or two charged particles is directly proportional, that is F is directly proportional to the product of the charges, that is Q1 and Q2, and also inversely proportional to the square of the distance between these two charges. Now that is what Coulomb's law. Now the question says which of the following action would increase the electric force between two positively charged particles. Now this electric force between these two positively charged particles can only be increased, that is, increase in this force can only be gotten when the charges or the quantity of the charges is increased, that is, when there's an increase in the quantity of the charge, and also when there's a decrease in the distance between the charges or particles. Now this is because the force is inversely proportional. The electric force is inversely proportional to the square of the distance between these two charges. So therefore, decreasing the distance will increase the force, and increasing the distance will decrease the force. And the question says increase the electric force. So therefore, decreasing the distance would increase the electric force, and that is option B, decreasing the distance between the particles, as stated by Coulomb's law. Thank you, and just subscribe to our channel for more videos. Good day and welcome. I will be answering Wassce 2020 Physics Past Question, question 46. A luminous object is one that A. gives off dim blue-green light only in the dark, B. gives out light of its own, C. shines by reflected light only, and D. glows only in the presence of light. Now, a luminous object is an object or is one that generates and emits lights themselves. So luminous object are object that has the ability to generate its own light and also emit this light. Examples of these luminous objects include the sun, the stars. You see that the sun and the stars has the ability to generate their own light and also to emit this light. So therefore, luminous object is such that can give out its own light, and that is option B. Thank you, and sure subscribe to our channel for more videos. Hello, good day and welcome. I will be answering Wassce 2020 Physics Past Question, question 47. Which of the following units is not fundamental? A. Meter, B. Kilogram, C. Joule, and D. Candela. So we are asked for a unit that is not a fundamental unit. Now, first of all, what are fundamental units? Fundamental units are units, or we call them basic units of fundamental quantities. Fundamental quantities. And like we know, fundamental quantities are are basic quantities from which other quantities can be derived. So in other words, we can say fundamental units are units from which other units are derived. Now these fundamental units are units of fundamental quantities. Example is the length of the fundamental quantity, and the fundamental unit is meter. Likewise, you have the temperature. The unit is Kelvin. We have the luminous intensity. The unit is is candela. We have mass. The unit is kilogram. Now all these are fundamental quantity with the fundamental units. Now the question says we should pick an option which is not a fundamental unit. That means the unit is a derived unit. Now from this you see that option A is a fundamental unit, the unit of length. Likewise, B, kilogram, is a fundamental unit, the unit of mass, and D, candela, is a fundamental unit, the unit of luminous intensity. Now option C is a derived unit, and this derived unit is a unit of of work or energy. So joule is a unit of work or energy, and like we know, work and energy are derived they are derived quantities. They are derived quantity. Now joule can also be expressed as kilogram meter square per second square. So kilogram meter square per second square. This is the representation of joules, and this is to tell you that joules is derived from the kilogram, the fundamental unit, mass fundamental unit, and second, which is fundamental unit. So therefore joule is the answer to this question, because joule is a derived unit. It is not a fundamental unit. Thank you very much, and subscribe to our channel for more videos. Hello, good day and welcome. I will be answering Wassce 2020 Physics Past Question, question 48. The vacuum between the double walls of a thermoflask reduces the heat loss through A. Conduction and radiation, B. Convection and conduction, C. Radiation only, and D. Conduction only. Now, they say the vacuum between the double wall of a thermoflask. Now, what is a thermoflask? A thermoflask, or what is known as a vacuum flask, has a double walled glass vessel. A double walled glass vessel with a vacuum between the walls. That is, there is a vacuum between the walls. Now this vacuum, the vacuum is to what? Is to reduce heat loss or gain by conduction or convection. So the vacuum between the double wall of a thermoflask is actually to reduce heat loss via what? Via conduction or convection. And like you know, conduction is just the what? Conduction is loss of heat via what? Heating a material medium, where convection is the loss of heat in what? In fluids. So the answer to this question is option B, convection and conduction. Convection and conduction. Thank you and God bless you. Ensure to subscribe to our channel for more videos. Hello, good day and welcome. I will be answering Wassce 2020 Physics Past question 29. In photoelectric effects, the number of electrons emitted per second from a metallic surface is proportional to the A. Intensity of the incident radiation, B. Frequency of the incident radiation, C. Energy of the incident radiation, and D. Work function of the metal. Now, in a photoelectric effect, when light ray or light falls on a metallic surface, electrons are emitted. Now these emitted electrons are what we call the what? We call them the photoelectrons. These electrons that are emitted are called the photoelectrons. Now the maximum kinetic energy of these emitted electrons, the maximum kinetic energy, that is the maximum Ke of the emitted electrons or the photoelectrons, is independent of the intensity of the incident radiation. That is, it do not depend on the what? Intensity of the incident radiation. So therefore making what? Option A invalid. So it is independent, it does not depend on the what? Intensity of the incident radiation, but is proportional to the frequency. It is proportional to either the frequency or wavelength of this what? Of this radiation or the incident what? Light. So therefore the photoelectric effect, the number of electrons emitted per second, which is the what? Energy of these what? Electrons from a metallic surface, is proportional to the what? To the frequency. It's proportional to the frequency or to the wavelength of this incident light. And from the option here, frequency of the incident radiation is given to us, so we pick it as our answer because it is proportional to either the frequency or the wavelength. And since the frequency is given to us, we pick frequency as our answer. So the answer to this question is option B. It do not depend on the intensity at all. So the answer is what? Option B, the frequency of the incident radiation. Thank you and God bless you. Ensure to subscribe to our channel for more videos. Good day and welcome. I will be answering Wassce 2020 Physics Past question 50. When two cells of negligible internal resistance and equal EMF, that is electromotive force, denoted by E1 and E2, are connected in parallel, the combined EMF is given by A. E is equals to E1 plus E2, B. 1 over E is equals to 1 over E1 plus 1 over E2, C. E is equals to E1, which is equal to E2, and D. E is equals to E1 all over E2. Now we're given that two cells of negligible internal resistance are and equal EMF, denoted by E1 and E2. Equal EMF, meaning that the electromotive force of the first cell E1 is equal to the electromotive force of the second cell, E2, and they are connected in parallel. That's parallel was connection. Now it says the combined EMF is given by. Now when cells are connected in parallel, now the EMF of this cell, E, the total EMF passing through this circuit is equal to each of the EMF. That is, the total EMF E is equal to the EMF of the first cell, which is also equal to the EMF of the second cell. But if it was to be in series connection, if they were connected in series, then the total EMF will be equal to the sum of the first EMF, that's the EMF of the first cell, that is electromotive force of the first cell, plus the electromotive force of the second cell. But because it is in a parallel connection, the total EMF is equal to the individual EMF, and that is why the EMF of the first cell is equal to the EMF of the second cell, because they are connected in parallel connection. So the answer to this question is option C. E is equals to E1, which is equal to E2, because they are in parallel connection. Thank you and God bless you. Ensure to subscribe to our channel for more videos.